Hi there, this is Anton from ORS, and in this video, I'm going to show you a nice segmentation of battery overhang regions using Segmentation Wizard. I'm actually going to do it different than usual. I'm not going to run through each and every step, and I will rather explain the steps and show you on process data what I did and how to achieve this nice result. So I've got a data set open here. This is a slice image of a CT scan of this battery, which you can see quite a lot of material here. The region of interest is this overhang. So what you would usually do is you would measure, like with a ruler, you would make linear measurements of this overhang region of interest. So for example, and by the way, at this point, maybe I can just explain that this data itself, if you click on the image channel, nearest means the pixels itself. And just to show you that these kind of measurements, forget about the contrast now, these measurements do not snap to voxels. These are sub-voxel measurements wherever you place the cursor or the measurement. In the next version, we have also some other tools in the pipeline, but okay, that's not in the scope here. I just wanted to show you that if you want to view the voxels and understand these measurements are actually quite precise to more accurate than a voxel if you have enough contrast. Okay, so what I want to show is if you do another linear measurement, what might happen is you have some text overlapping. So the way to get around that is use the floating caption possibility. So this is new. And if you use that for each ruler, you can nicely organize all your linear measurements. So you can do many anode measurements like that linearly in slices, but of course it would be quite nice to threshold to segment out these overhang regions. So what is the problem? Why don't we just do it automatically? Well, if you're using traditional thresholding methods, that's a bit bright. I can change that opacity a bit. But if you're changing the threshold and make the threshold within a certain range like that, you can reach some kind of success, but you see the problem. It's missed in some places and it's capturing all kinds of other things, and it's messy all across. It's in many slices across the image. It's you cannot easily get a good range for that kind of measurement. So that's the problem really, and that's why deep learning works quite nicely. What I did here is I used Segmentation Wizard, which I will show you in a minute, but I used Segmentation Wizard to train a deep learning model. And I used not the entire data set because deep learning uses image recognition techniques. So it recognizes certain things in images, and we are not interested in this top part here. So I cropped the data to only an area of interest there. Actually, I could have cropped it even further, and that helps to more easily train a model for this region to identify and to converge to a good solution like we did here. So the final solution looks like this. Actually, the multi-ROI looks like this. So it segments those regions out, and I can demonstrate how to apply that as follows. So if I click on the image, once you've got a model trained, how it works is you select your segmentation model here, which is called battery overhang in this case. And I simply, for a particular slice, let's choose a slice looking like this. And we click on preview. So what that does is it takes that entire model, applies this image to it, and does a segmentation of this image only. So it's not segmenting the entire data, it's only the slice, as you see there. But as you see, that's quite a nice segmentation. And now I will show you that basically when you want to apply a model, there's no human bias or thresholding involved. You simply apply to all slices your previously trained model. Of course, if you have many batteries with similar image quality, you will be able to use the same model on all of those scans to get this kind of result, and then make your thickness analysis and overhang analysis from that. So let me show you how I did this in Segmentation Wizard without running through all the steps. Basically, you find Segmentation Wizard up here at the Artificial Intelligence Segmentation Wizard. Usually I applied a new one, but in this case, we're going to have a look at this inverted cropped region, and I will show you what I did there. I had 5 training frames, which I painted, which look like this. I painted them using this Smart Grid tool. As you see there, it does quite a good job in 2 dimensions, and I fixed it up using the here and there with a paint tool there around a full 2D brush. So I did that for a number of frames, 5 frames and 1 monitoring frame, and I used a U-Net, attention U-Net in particular, to train the model. The nice thing about this training, you can then actually in Segmentation Wizard, maybe I can refer to other videos for that, but each time that you train the model, the monitoring frame, you don't have to do 5 frames in the first instance. You can train 1 frame, do some training, and then if you have a new, let me demonstrate this. If I have a new slice like that, I can do let's say I want to use this as a new frame. So I would add a new frame here. And what I would do is I can use my model, which has already been trained, to provide some data, or we can manually train it. So I can manually do this. So I can, for example, paint like this, or I can just simply take my model and promote this kind of segmentation, maybe just fix it up a little bit. So in this case, if I highlight both the red and green classes and I use a brush there, I can fix up on the edges there. And then this would be now a new training frame. And then each time you can add more training frames, and in that way make your model stronger and retrain and continuously retrain. Okay, so that's how I achieved a good model, and I'm not going to do any more here. Basically, before you leave, you need to save your model with a name so that you can recognize it in order to apply it. So just to keep in mind, training a model doesn't mean you actually apply it to the entire data yet. You need to actually still apply it. Okay, I hope you enjoyed that. I hope it's useful, and happy deep learning.